Asyle, the engineer, and the island. Week 13, Day 1. Into week 13, and feeling a lot cleaner, I decided to continue my break from my larger projects in order to complete a bunch of the smaller ones, taking it relatively easy. I've worked a lot, and this light work will help me to avoid burning out. On that topic of burning, though, the dry season has almost certainly set in, which means it was, in some ways, a bad time to build a bathhouse, as the rivulet is starting to dry up, but in some ways a good one, as it'll act as an extra reservoir with which I can keep watering my garden. I'll just need a way to get the water back uphill. If the rivulet dries up completely, though, I may need to start distilling seawater again, and a lot of it to keep everything hydrated around here, not just me. I have an idea for that, but it's going to be a very big construction project. Concrete has been doing a good job for me so far, so after my morning chores, I'll start the cycle again of cooking and stockpiling lime every hour or so. I'm not entirely a fan of the process of making it, because I know that I'm adding more CO2 to the atmosphere, like the rest of the world, but at least I'm not burning coal to make the heat. It would be nice if I could capture it somehow for something. It makes me think of the bubbles in soda, which I also miss, and the bubbles in baking soda and vinegar, or in bread, and it makes me wonder if I can make my concrete even lighter and stronger somehow by adding bubbles to it. I considered a few options, some kind of leavening chemical reaction seeming best, but it would require a way to also give the material a greater surface tension to hold on to the bubbles. I think that sort of thing is beyond me at the moment, and besides, I have pumice, which is functionally the same thing. In the meantime, I needed some water pumps, so I used the latex I collected this morning to make another diaphragm pump. I also prepared a clay pot that I could install the pump in, for two reasons. The first was that I wanted to set at least one of these pumps in the ocean, and by mounting it to a pot that I could fill with rocks, I could weigh it down to the bottom. The second was that I wasn't sure if the pipes would be able to handle being placed under suction. The latex could delaminate from the bamboo walls and plug up the pipes or rip. So instead, I'm thinking that the pumps could just push the water uphill and dump it into the pots in stages. If one of the pots runs out, it'll just pump air until it fills up again. If one of the pots overflows, it's no big deal because there's plenty of water in the ocean. While I waited for the rubber and pot to set, I cut down some bamboo, some of which I hollowed out and laid in a line from the base to the beach. I poured the rest of my latex down the tubes to act as pipes once the latex dried. It's awfully convenient that way. With most of the rest of the bamboo, I started building a platform to cover the pool so I could start tiling the ceiling. It wasn't terribly complicated, but it did take a while. When I was finished with the basic framework, I took a break before splitting a lot of the bamboo into long slats that I could use to make a nice, relatively flat floor, which I tied down to the framework with cord. Finally, I added a couple of rollers on one end to make sliding it on and off the pool easier. It's a little flexy, but it'll definitely support my weight. I can fix that later. With the material I had left, I built a couple of extra fans and wind turbines for the kitchen and beach hut, just to help keep things cool, though not as big as the one powering the lab's exhaust fan. I installed them before the sun went down, and started doing a little tiling for the bathhouse ceiling before starting my new evening routine of showering, having dinner, and brushing my teeth before bed. Week 13, Day 2. After my morning chores, I prepared another diaphragm pump in the pot, and finished constructing the first ones. I then took my pot, some rocks, some cord, and a coconut float to the beach, and assembled them into a wave-powered pump. As the waves go up and down, they carry the coconut up and down with it, pulling up and down on the stones, which rest on top of the diaphragm, causing it to pump. I hooked the apparatus up to one of my dried bamboo pipes and waited out until I was just outside of the reach of the tide, so the pump would always be submerged. In order to make sure it could handle the changing tides, I tied coconuts and stones to the pump in a series along the cord, making sure that each stone had the same weight as the coconut's buoyancy force. This way, if the tide rises up past the height of one of the coconuts, another will rest at the surface to take its place, and it'll likewise lift one of the weights off the diaphragm. This chain will continue all the way from low tide to high tide, so no matter what, the diaphragm will always have an oscillating force of one weight acting on it. Fortunately for me, I didn't have to do this many times, because tides are pretty shallow near the equator. The little waves soon created a detectable spurting of salt water at the end of the tube. I carefully jointed the pipes together to see at what point up the slope the pumping stopped. It turned out to be not very far at all, which was more or less expected, since these pumps don't generate a great deal of pressure. Their strength is in their ability to harness oscillation. I started digging a pit at the end of the tube for the next pump, and then remembered that I could coat the outsides of my pipes with latex like I did for the refrigeration system, fixing the potential suction problem. I don't know how I forgot that. So I spent an hour or so carefully pouring latex across my pipes, using the lathe to spin the pipes for a thin, even coating. The intermediate reservoir pot won't go to waste though. While I waited for everything to set, I got some more bamboo and started building several small wind turbines to power the diaphragm pumps in stages up the slope to my base. I've gotten good at building little wind turbines lately, and in this design, the trick was turning a vertical axis rotation into an up-down oscillation. It turned out that this wasn't so hard after all, because all I had to do was mount the turbines on their sides at the top of a small post, like a water wheel, and connect a camshaft to it to drive the pump. I expected this design would even be able to derive a little power from rainfall. I basically mounted two horizontal turbines on the end of a shaft to keep them balanced, and put a vane between them to make sure it rotated to follow the wind. It looks so wonderfully bizarre. I absolutely love it. I stopped for lunch at this point and then built a few more turbines. I didn't expect that they would be able to produce more than 5 or 6 feet of pressure head, so I made 6 of them, right up to the end of the day. They should be more than enough to deliver salt water right up to the center of my base, with some left over to pump water back up to the garden. As the sun went down, I got ready to start tiling the ceiling of the bathhouse some more, but I was still not comfortable with how saggy the platform was. So I stopped and used some bamboo scraps left over from building the turbines to make a couple of hinged A-frames, which sat underneath the platform and provided support. I had to fill them with sand to weigh them down so they would sink in the pool, and the hinge allowed them to fold flat against the underside of the floor frame when I moved it. I also took care to make the feet of the supports broad so they wouldn't cause any damage to the floor of the pool below. By the time I was done with it, although I was quite pleased, it was really too late to do any tiling, so I just took my shower and got ready for bed. Week 13, Day 3. After my morning chores, I used most of the latex I collected this morning to start building the last few diaphragm pumps. With the one I finished building, I tested out one of the wind turbines to see how far up the hill it would pump. There always seemed to be a slight breeze here, and fortunately I made the turbines light enough that they turned easily. I had to extend the lever arm on the camshaft a little to get easy pumping, but I was pleased with it when it was done. I was only about an hour into the working part of my day, and I'd already run out of things to do. Most of the things remaining on my to-do list were kind of beyond my capacity at the moment, except maybe one. It had been a few weeks since I mined those minerals from the cave, and I checked to see if they were leaching as expected. The water was definitely a little more acidic, but at this rate it's going to take forever to separate the sulfur from the metal significantly more. I want to separate them via electrolysis, so it's finally time to stop putting it off. It's time to build a Van de Graaff generator. Fundamentally, it's actually a very simple machine. that works on the same principle as a static electric shock, just like every time I got up from the couch at home. Different kinds of materials hold on to electrons more strongly or weakly than others. When you put them next to each other, the material that wants electrons more will hold on to them, causing both materials to accumulate a different charge. Instead of rubbing cloth on the couch all day, though, the Van de Graaff generator uses a belt that rolls across two rollers of different materials. This should actually be easy to make with the materials I have. I quickly whipped up a little frame and two bamboo rollers. I wasn't sure what materials I had that would be best to cover the rollers in. All I remembered from various electronegativity charts I've seen in the past is that generally ceramics are on one side of the spectrum and polymers are on the other. So I coated one of the rollers in the last of my latex for the day, and the other I surrounded with clay to make a cylinder, and I left it out to dry for the day. The salt glaze that'll form on its surface should be almost identical to glass. Finally, I cut a small swatch of cloth from my stockpile and sewed it into a belt. It took almost no time at all to build this, but I recognized a bit of a problem. Normally, to get electricity off the rollers, it's picked up by a metal comb or brush, which transfers them to big metal spheres that you can make sparks between. It's an ironic catch-22 that I need electricity to make metal, but I need metal to make electricity. I just need something that's conductive, and the only other decent electrical conductor I have right now is carbon. So, praying the whole way, I made some simple bamboo brushes, pulverizing the edges with a rock, and coated them in a sort of carbon paint I made by mixing charcoal dust with water. I did the same thing with some cord to make wires, thinking to myself the whole time that this entire machine is going to be as dodgy as all get out, but I didn't really have any other options. In addition to the roller, I made some partial cylinders and flat tablets out of clay, the former to protect the generator from wind that might blow charges away, and the latter to create a nice flat surface to electroplate onto later. Even this job didn't take me much longer than an hour before I was stuck waiting again, so I looked around the base for something to do. I decided to start tiling the ceiling of the bathhouse early, and I finished up to the point that the scaffolding got in the way. I decided I might as well see what would happen if I began taking the scaffolding down, carefully untying the joints holding them together, starting at the top where I expected the concrete to be weakest. I kept a careful watch for sagging and cracks. There's a reason they didn't build a lot of solid domes like this in the ancient world, and why most of them had holes in the top. There's really nothing supporting that top flat section except the shear strength of the concrete, which is pretty weak. At the same time, in order for those top sections to fall out, they would have to push the bits of the dome below them to the sides to make room, and this gave me an idea. I stopped dismantling the frame and tried to put it back the way it was. Instead of supporting the frame from underneath on the inside, I could squeeze it a little from the outside. That squeezing force should cause the slopes of the dome to push in on the bits at the top to hold it all in place. I'm no architect, but it occurred to me that this might explain why some large domed buildings, like the Capitol building in Washington, D.C., may have that characteristic vertical ribbing on the outside. I cut down some more bamboo and bent it into arcs to create the desired ribbing structure on the outside of the dome. I used a little cord and a peg between arcs on either side of the dome to apply the squeezing force, and tied it as tight as I dared, counting on the scaffolding underneath to prevent the structure from being squeezed tighter than it could handle. I then covered the ribs with a mix of clay and lime to both protect the ribs from the rain and make them heavier so they wouldn't have to rely on tension as much. I could probably put a weight on the end of a lever arm to increase that force, but one, the resulting weight might crumble over time due to bending stresses, and two, they would kind of look like a crown of Gothic spires on the top of the building, which, while cool, wasn't the aesthetic I was going for. I left that to dry and had a late lunch. While I sat in the kitchen and chewed, I was still looking at the bathhouse and admiring how nice it looked, even with the cover over the pool. I was getting a little tired of stopping to eat lunch wherever, usually sitting on the ground, and I got an idea to turn the bathhouse into a part-time dining room, since I still don't have anything better to do. I got some more bamboo and started crafting a table and chairs. The table took a bit longer because I decided to give it the same bamboo slat treatment that I gave the floor beneath it, though this time I got to refine my technique and made the tabletop much smoother. If I had something like resin, I could probably fill in the cracks to make it super smooth. For the chairs, I used the loom to make a nice weave of bamboo cord, which gave them a nice support for the seat and back. This took me to the end of the day, and I was sort of pleased with it. At the same time, though, it kind of reminded me of my grandma. She used to have this big, fancy dining room set, but she never had guests over for dinner. I wondered to myself if I was kind of doing the same thing. In a weird way, being ready to have other people here somehow makes the dumb part of my brain think that someone's going to be here, and that relieves the loneliness a bit. If nothing else, it'll give me an additional work surface. Week 13, Day 4. I began the morning, after my chores, by completing the assembly of my pumping system, which didn't take too long. There were a few bugs and leaks to fix, but in the end, it seemed to be working just fine when the wind was blowing. Now I just needed a spare moment when the kiln wasn't being used to cook lime to test it. I also needed a rubber hose for the very end to move the salt water where I needed it, so I spent an hour building one with the latex I collected this morning. I was still short on things to do, so I decided to just sit down for a while and carefully plan what I wanted to build next week, and estimate what materials I'd need and how long it would take. The process was more involved than I expected, and I found myself taking a few wrong turns, but the results were interesting. Basically, what I want to build is a giant concrete tower to rest my solar array on top of. It has a diameter of about 3 meters, like most of my buildings, and it'll be about 14 meters tall, not counting the solar array at the top. Its purpose will be to produce and store distilled water for the dry season, and its great height will store it at high pressure, so I can use it to power my workshop even if the rivulet completely dries up. I needed to calculate, though, how thick the walls would need to be to support all that weight, and I'm not sure if I made a mistake in my calculations or something, but apparently concrete is so strong in compression that the walls would only need to be 5 millimeters thick, which is obviously unworkable and doesn't take additional stresses into account, like bending from the wind or pressure head from the water inside the tanks. It was a lot to calculate by hand, and I had to keep going back and correcting mistakes, so I changed tack and first calculated how tall I could stack bricks of the same cross-section before they would collapse under their own weight. This turned out to be a little over 500 meters, or 200 stories, including a safety factor of 2, not that I planned on building any skyscrapers anytime soon. What this meant was that I could make my bricks any size, and they'd be able to support the weight of the bricks above them, so long as the tower was below this height. Any additional thickness of the bricks would need to be for supporting the weight of the stuff I planned to put on or in the tower, in this case, mostly a lot of water. I was planning on giving it 5 levels with domed ceilings for support, kind of like the partitions in the bamboo I've been using. The beauty of this design is that each level individually is under a maximum of 2 kilopascals of pressure from the weight of the water at their bases, but they can be added together like a battery to generate up to 10 kilopascals of pressure when the tower is completely full. Of course, this pressure is also acting on the bricks at the foundation of the tower, so how big do those bricks need to be? If I use the same logic for my maximum concrete height, however, it tells me that no matter how wide the bricks are, they'll be able to support a water column of up to 12 kilometers before they start to break. Only above that height will the bricks need to be wider than the water column. For all practical purposes, this basically means I can make the bricks as large or small as I want. Well, that trick should save me some math from now on, at least as far as compressive forces go. Next, I need to keep in mind the forces acting on the walls of the water tanks from pressure. The pressure is going to be equal to the density of the water times the height of the water times gravity. So if each level is filled to about 2 meters high with water, that's going to be a pressure of about 2 kilopascals or 0.2 atmospheres as mentioned. Some of this force is going to be applied as shear between the bases of each level, but most of it will be as tension in the walls. I don't know the shear or tensile strengths for my concrete mix, but I remember hearing somewhere that concrete's tensile strength is about 1/10 its compressive strength. I tested my concrete to have a compressive strength of about 4,000 psi, or 27.5 megapascals, so its tensile strength should be 2.75 megapascals. If I assume that the wall of the tank behaves like a thin-walled cylinder, then the tensile strength it experiences will be equal to the internal pressure times the radius of the cylinder, divided by its thickness. Sigma equals P times R over T. If I rearrange that equation to solve for thickness, I get 1 millimeter, which is obviously unworkable, but also means I can pretty much make the walls as thin as I like, and they should be able to handle the stress. Still, I'm kind of surprised that concrete could be so thin and still handle that much pressure. Now I need to calculate how many bricks I'll need, and how much lime, clay, and pumice I'll need to make them. If the bricks are 10 centimeters thick, and the tower has an inside diameter of 3 meters and a height of 14 meters, then it'll have a volume of about 13.7 cubic meters. Let's add an extra 50% to be safe, for about 20 cubic meters. For a concrete ratio of 6.67% lime, 13.3% clay, 40% sand, and 40% rock, that means I'll need 1.3 cubic meters of lime, 2.7 cubic meters of clay, 8 cubic meters of sand, and 8 cubic meters of pumice. 1,000 liters is 1 cubic meter, so that's 1,300 liters of lime, or 162 batches. I'm getting about 10 batches done per day, so that's about 16 days or a little over 2 weeks. Good thing I started this week. I can almost certainly stack bricks as fast as I can make lime to make them out of, so I might be able to finish the tower by the end of next week. I thought this would be at least a 2-week project. There's something else that needs to be done first, though. My plan is to put an elevator shaft up the center of the tower, which will help me move all the materials up as I build. This is going to require me to build a tall tower out of coconut trunks, though, to not only make the shaft, but also to support the solar array, as it really is built right now for that support structure. I just need to make it taller. I'm almost regretting not making it super tall from the beginning, but I recognize that that would have been stupid when I didn't know whether or not it would work, and I would have had to lift a metric ton of stone 50 feet up in the air. It took me a couple of hours to make my calculations and more or less finalize my designs, so once I was done, I had lunch and sharpened my axe in preparation for cutting down 6 more coconut palms. I took several sprouting coconuts with me to plant at least 2 trees in place of every one I would cut down. I looked around for the tallest and straightest ones I could find, the tallest being up to 60 feet. It took me about an hour to cut each one down and drag them to the beach with my log sledges, so I didn't finish before the sun went down. Why do I keep realizing I'm running out of time to do everything I need to do in the middle of the week and at the end of the day? Again, this is probably because I didn't do enough planning. When I got back to base in the evening, I realized I had another problem. The current solar array is right where I want to put the new tower. I'll have to take it apart to put in the new tower, and in the meantime I won't be able to use it for cooking lime. I'll just have to deal with that tomorrow, though. All I can do right now is get ready for bed. Week 13, Day 5. After my morning chores, I immediately began carefully disassembling the solar array before it could get too hot, starting with the reflectors, which I gingerly lowered to the ground and dragged to the side. Next, I had to get that heavy kiln down. I briefly considered just letting it crash to the ground and starting over from scratch, but that would have been a waste of time. All I could really do was reverse the process I used to get it up there, inching it back down one corner at a time, which was less effort intensive but scarier, as I had to be extra careful to keep it from crashing down on top of me as I went. After a couple of hours, I managed to lower it back down onto some rollers, and I rolled it out of the way. I then got some cord and finished getting the logs back to base, floating them in the ocean and towing them along from the shore, which was a bit easier than lugging them by hand. I used some sticks and scrap bamboo segments to at least make it easy to drag them up to the base. Next I had to erect them, and this was going to be much harder than with the last ones, because these trunks were so tall. I started though by digging out the holes for the old posts, and getting them out of the way before modifying the holes with a slope on one side where the new tower posts could slide in. I stopped for lunch and a much-needed break before erecting the trunks. And fortunately for me, I had the slope and a long rope to help me with this. I basically had to pull from the back end of my garden to get an adequate lever arm on the trunks to get them upright. To make sure they didn't collapse on any of my buildings, though, I tied some guide wires to them so they couldn't fall in the direction I was pulling. I tried to start on the mountain side of the tower, so the guide wires wouldn't tangle into each other too much as I erected each post one after the other. Once they were in place and I double-checked their positioning, I got some bamboo and built a triangulated framework around the base to keep them in those positions, though at times they required some persuasion with a big hammer. The holes I dug for the pylons were a little over 1 meter deep, and I filled them in with concrete once I had the posts where I wanted them, so they would never move again. I then spent the rest of the day building more scaffolding up the tower for each level, being careful to measure from the inside of the pylons so that the diameter of the elevator shaft remained the same all the way up, tapering a little from the outside in because of the shape of the trunks. This is fine because it should help give the structure a little more stability when I start building masonry around it. I made sure to build rungs into the structure as I went to make it easy to climb, and I tied 2 ropes around my waist to the secured parts of the structure using slip knots, so that when I had to retie myself to a different side, I was always still tied to at least one lifeline. It was scary though, because if nothing else, the Mythbusters have taught me to fear 2 things: MGH and 1/2 MV squared, i.e. heights and driving on the freeway. It was dark by the time I finished the last level at the very top. I took a few seconds to admire the view from up there, but I couldn't really enjoy it because I was still trying to hang on for dear life, so I carefully crawled my way back down the tower and got ready for bed, feeling a bit shaky the whole way. Week 13, Day 6. My mission is clear today. Get the solar array cooking again as soon as possible. That'll probably take all day though, so after my morning chores, we'll get cracking. There's no way I can carry everything up the access ladder, so I'll need to build the elevator first. This is complicated, however, by the fact that when I designed the elevator shaft, I didn't think about leaving room for a counterweight. Failure to plan biting me in the rear again. This oversight may have been a good thing, though, since I would have otherwise had to have made the whole shaft bigger, and that would have been wasted space. Instead, my new plan is to put a counterweight under the elevator shaft and use lots of pulleys to magnify its mechanical advantage. I need a minute to remember the rules for how pulleys work first, though. If you have one pulley at the top of an elevator, the simplest design, the effort to lift the weight at the other end is equal to that of the weight, 1-to-1. But if you have 2 pulleys, one at the top of the shaft and one on the weight, then you have to pull twice as much rope to raise it the same amount as with one pulley. Conservation of energy applies here. PE equals F times D, or potential energy equals force times distance. So you only have to pull on the rope half as hard, even though you're pulling it twice as far, 1-to-2. And this pattern repeats for as many pulleys as you add, a ratio of 1 to n. This is actually a good thing for my elevator because I want the rope to move a very long way, namely to the top of the tower, but for the weight underneath it to move a very short distance, since there's not a lot of room for it to move to begin with. The thing with this design is, when the elevator is on the ground floor, the weight will be right up against the bottom of it, and all the way down against the ground when the elevator is at the top of the tower, so I'll need to dig a little pit at the bottom of the shaft to hold the weight. I don't want to dig much lower than the foundation of the pylons, though, since that would give them somewhere to shift, so I can't let my weight rise more than 4 feet or so. If I use that for my counterweight rise distance, then in order for the elevator to go up about 6 stories, or 48 feet, conveniently for the math, that means I need 12 pulleys. As for the size of the counterweight, an average adult male like me weighs about 80 kilograms. The elevator car itself will probably be made of bamboo and therefore won't weigh much, so let's say the thing weighs about 100 kilograms when loaded. I can make up the difference myself when I'm raising or lowering it, since anything above that weight limit will be divided by 12. That means the counterweight needs to weigh 1,200 kilograms, and if I make it out of concrete, it'll have a volume of about half a cubic meter, again, convenient for math. If I make it a cylinder about the same diameter as the elevator shaft, it'll only need to be about 2 feet thick. With a plan in place, I began digging a pit of the approximate size at the center of the tower, the pylon foundations now being set, forming a rough tube. I made sure to leave the walls lined with clay and sand, so the weight I planned to cast there would be easy to remove. I then took what rope and cord I had and used it to line the hole, forming a sort of loose net or basket, to which I can attach my pulleys, which will go around the edge, supporting the weight from underneath. Once I had it the way I wanted it, I mixed up some concrete and started filling in that part of the hole, using bits of granite instead of pumice, since I actually wanted this one to be dense and heavy. Next, I needed to start working on the rest of the elevator. I used the lathe to construct the pulleys, and I went to a little extra effort to make them well, since this is going to be holding me up very high in the air. They were kind of like the pulleys on old-timey ships, in that they would be held to their mounts by rope, just as well since they are going to be under tensile forces no matter what. What I did a little differently this time was that I actually made some small bearings to reduce the friction on these pulleys. This mostly consisted of 2 pieces of bamboo of different sizes, with small sticks trimmed to a particular diameter between them, the centerpiece of bamboo acting as the axle which was mounted or hung. As mentioned, I made 12 of these. Then I started making rope, and a lot of it, nearly 600 feet of it, which I made sure to twist together into proper strands, since I didn't think bamboo cord by itself was going to be nearly strong enough. No point in taking chances anyway. At this point, I stopped and had lunch before getting started on assembly. I couldn't actually use the elevator until the concrete counterweight had set, so for the moment all I could do was begin assembling the rigging. I tried to do this on the ground, getting all the rope laced together properly, before taking one end to the top. Otherwise I would have had to keep climbing up and down the tower to lace the rope through each pulley, and that would have been a real waste of time and energy. On my way up to tie the upper pulleys, I caught myself having a Mythbusters moment asking myself, what the heck am I doing? Before getting on with it, because you don't question it when life's this good, I am building my own giant solar power tower after all. I left the pulleys slack so they didn't pull on the setting concrete at the bottom, and it looked pretty good, except for one thing. The ropes were in the way of the entrance, so I stopped to make a couple more pulleys that held them to the sides like a curtain. The concrete was set enough by this time for me to work around it, though not nearly sturdy enough to put any loads on, so I began working on the elevator car itself. I started by making a bamboo ring that laced through the loops I put in the pulleys. At this point I realized I had a little decision to make. Should I make this the ceiling of the elevator, or the floor? Making this the floor of the elevator might cause a few stability issues as the elevator rises through the shaft, and it would require me to move the pulleys at the top of the shaft one more level down. But it would also make better use of the space at the bottom of the elevator when it's fully lowered, and the ropes wouldn't get in the way at the top of the shaft. And one concern with putting the pulleys at the top of the elevator car is, if anything ever goes wrong with the elevator, the bottom half of it could fall all the way to the bottom of the shaft, with me in it. Since I'm going to be spending basically all of next week bringing masonry up and down this thing, I think I should go with the safer option. I didn't move the pulleys at the top of the shaft just yet, because I'll need to take it to the very top when I install the kiln later. Instead, I began building on top of the ring I built, making sure to space the pulleys around its perimeter evenly. Naturally, I made a nice sturdy framework in the center of the ring and tested its weight-bearing capabilities before I started making a proper floor, again using bamboo slats like the table, because I anticipate having to slide the heavy kiln on and off this thing, and I wanted a relatively smooth surface for that. I then began constructing a cage on top of the platform for two reasons. The first was to keep my easily damaged body parts away from the ropes in the elevator shaft, and the second was to help keep the elevator stable and level as it rises. The round surfaces of the bamboo I'm using to build it should allow the ropes to easily slide over it and keep it vertical. But just to be extra safe, and to help deal with the aforementioned stability problems, I put some rollers around the perimeter of the elevator's roof to make sure it'll rise smoothly. I made most of the elevator cage with arches because I'm planning on using the roof to replace the little dumbwaiter I had to lift stuff into the kiln with before, and as such, it would have to bear the weight of the kiln's floor and anything on it. Much more convenient in some ways, though in others it also reminds me of a mist-like puzzle, kind of like the elevator in the center of the mechanical age, which only makes me like the idea more. Finally, I spent some time in the workshop building a ratchet wheel and crank to make it easier for me to raise and lower the elevator. While I was at it, I built another little flyball governor that operated a brake on the ropes, so the elevator would never descend faster than I wanted it to. This gave me an idea for one more safety feature, which is pretty simple. I made one more large ring of bamboo and coiled it under the floor of the elevator, such that it fit within the elevator shaft. I held it under tension with a bit of bamboo cord, which I tied to the pulleys on the floor of the elevator, such that if those pulleys ever lose tension, which would result from a break anywhere in the elevator's block and tackle, the cord would become slack, which would in turn allow this final bamboo break to expand and jam the elevator shaft so it wouldn't continue falling. I was really pleased with all these little safety mechanisms and installed them into the elevator. Before it got dark, I gave myself one more task, and that was to fix a long-standing problem with the kiln before I put it back in place tomorrow. I mentioned how the little windows at the top of the kiln let heat out from convection, and all the things I went through to try and remedy the problem. These still resulted in some losses and inefficiencies, like steam from cooking items scattering the light trying to get in. I realized, though, that there was a simple solution for both of these problems. Put the windows at the bottom of the kiln. It's so simple, I've kind of been kicking myself for not thinking of it from the beginning. So in the twilight hours, I alternated between my drill and a makeshift chisel, slowly etching away at the bottom of the kiln and sealing up the old windows as I went. I took care to apply as much of the chiseling force as possible tangentially to the kiln's surface, so I didn't risk cracking it. After that, I got ready for bed and collapsed, looking forward to a Sabbath rest tomorrow, though knowing I still have some assembly work to do to get the solar array running again. Week 13, Day 7. It's finally the Sabbath, and after that mad dash to build the elevator tower, two phrases you never want to hear in the same sentence, I could almost take a break. First, though, I had to put the solar array back together at the top of that big, scary tower, so after my morning chores, pulling all the ropes taut for the elevator and testing it for safety, I grabbed some bamboo and rolled my kiln gently onto the elevator. There was barely enough room for both of us in that tiny elevator car, and even though the combination of the counterweight and pulleys cut its weight down by 12, that was still about 60 kilograms I had to crank. I quickly realized this wasn't going to be practical, so I got some pots, filled them with rocks, sand, and anything heavy I could find, and added them to the counterweight, lifting the elevator car just high enough that I could fill the pots underneath, but could still climb into the elevator. I needed about 8,600 kilograms to completely offset the weight of the kiln, or an additional 3.5 cubic meters of concrete, which wasn't going to happen. I was happy just to cut its weight by a quarter, but that was still about 15 kilograms I had to crank over a distance of about 600 feet. Eventually, I made it to the top of the tower, though I made sure the car stopped just one level short of its maximum elevation. After a short break to rest my arms, I tied my safety line and started building a small platform at the exit of the elevator, facing the ocean. I made sure it was supported by strong ropes to the pylons above, because I then gently rolled the kiln onto it. I thought to myself over and over again how stupid an idea this was, because I was placing a very heavy weight at the end of a very long, windy lever arm, and if it fell to the ground, it was going to have so much kinetic energy that it would probably leave a crater, assuming it didn't take out one of the legs of the tower first, with me at the top. As such, I secured it with cord to within an inch of its life, before moving on to the next step. I climbed out and lowered the elevator car one level before locking it in place with every braking mechanism I had. I then used the ladder on the side of the tower to climb onto the roof of the elevator car and gently rolled the kiln on top of it. I then brought the elevator back up to the top and raised the base of the kiln just high enough that I could get some supports under it, which I then tied down to the tower so the kiln was now properly supported. I am never moving that thing again. If I need it somewhere else or need to change the design, I'm just going to build a new one from scratch. I think the worst part is over now. So, after another short break to calm my nerves, I began working on bringing the reflector panels up to the top of the tower. This wasn't nearly as hard, and as I ascended in the elevator, noting how I actually had to expend effort to go down now that there was so much extra mass on the counterweight, I had an idea to make lifting the panels a little easier. I threw a rope off the top of the tower to reach the bottom, where I secured it to one of the panels. I then secured this line to the elevator at the top of the shaft and cranked the elevator down to the bottom. This caused a bit of a problem though, because I had to effectively raise the counterweight and the panel at the same time, which didn't give me a lot of mechanical advantage. This was fixed firstly by removing the excess weights from the counterweight now that I didn't need them, and secondly by lacing the cord around the tower frame and the panel frame several times so they acted as multiple pulleys. Once I reached the bottom of the elevator shaft, I tied off the cord so the panel stayed in place, before heading back up and securing it to the tower. Seeing how well that method worked, I repeated it with all the remaining panels at once, which was more effort, but I saved myself a lot of time. Once the panels were secured, I erected them and calibrated the rubber bands as before, so that it was finally heating up the way it was supposed to, only this time it was aiming the heat at the floor of the kiln for the most part, which was good since that's where most of the items I'll be cooking will be. As such, I made sure to install the floor of the kiln last, and added some cords to the locking and unlocking mechanism, so that I'll never be able to accidentally take the floor of the kiln with me down the elevator shaft. I'm still a little concerned about wind stress pushing on the panels because the wind is stronger up there, but I don't have any ideas for fixing it at the moment. I had a late lunch and could finally relax for the rest of the day. I started by finally taking those Van de Graaff generator parts out of the kiln and putting them together for a test. I've neglected this one way too long. I decided to set it up in the lab, using the power from the ceiling turbine to drive it. I was really apprehensive about it working correctly, but after I gave it some time to spin up, I brought my fingers close to each end and got a detectably strong jolt. This caused me to laugh a little maniacally, because I'd just created freaking electricity on a deserted island. Out of mud and sticks, no less. I tested my carbon-covered leads, and while there was still almost certainly a significant resistance, I still managed to get a detectable charge off of them. I found the cover of the generator really went a long way toward helping it retain a charge. After these experiments, I decided it was finally time to start my electroplating experiments. I coated the flat plates I made with carbon paste to give the electricity something to flow through and the ions something to stick to, but which would also be easy to remove from the plates since carbon is soft and flaky. I then gently immersed them in the solution of copper sulfate, since that was really the element I needed first for making wires to replace the carbon. I'm not really sure how long this will take. I just know that while a Van de Graaff generator can make thousands of volts, which is how it creates a spark big enough to see, it creates a very weak current. However, it's the current that makes the electrolysis happen. The way it works is that copper and sulfur ions are floating around in the solution, and when you apply a charge to the plates, the copper ions float to one side and the sulfur ions float to the other, the copper becoming stuck to the plate, and the sulfur reacting with the water to turn back into more sulfuric acid, producing pure oxygen gas in the process. At first I wasn't really sure which side of the cell was which, but just by remembering the formula for copper sulfate, I knew that the positive side of the salt was always the first in the name, and the negative side was always the second. That meant the copper ions would be positive and collect on the negative electrode. So I marked the electrodes as positive and negative once I noticed bubbles forming on the positive electrode. How fast this reaction occurs will depend on how fast these charged particles are moving through the water, that is, the electric current being pumped through the cell. A Van de Graaff generator probably doesn't make more than a couple hundred milliamps of current at best, probably more like microamps. An ampere is equal to 1 coulomb of charge passing through a lead per second, or 6.25 times 10 to the 18th individual electrons, or ions in this case, per second. Copper is atomic number 29, and has an atomic weight of just over double that, say about 60 grams per mole, and a mole is 6.022 times 10 to the 23rd particles. So using electroplating, I might be able to get 0.623 milligrams of copper per ampere of current per second. If I'm pumping, say, 100 microamps of current, that'll get me 62 nanograms of copper per second, or about 38 milligrams of copper per week, which is tiny, but honestly better than I was expecting. It occurred to me as I was setting up this reaction that the oxygen gas produced might also be useful, if I can find a way to capture it. I don't have a means to capture it in its pure form, so I need to come up with a way to chemically combine it with something else. The only oxygen compound I could think of that I found particularly interesting or useful was a material called potassium superoxide, which was used as an oxygen scrubber on Russian spacecraft and reacts explosively with water. However, I don't think that's a reaction I can achieve, since I think it requires pure potassium. I think what I can do, however, is make some potassium peroxide, which isn't as potent, but is still a very strong oxidizer. I should be able to create it by simply oxidizing potassium hydroxide powder, which I know how to make, and reacting it with water will cause it to release the oxygen again when I need it. Bingo! Solid chemical oxygen storage. As I started thinking about what kind of equipment this process would need, I realized I didn't really have time to finish it by the end of the day. Plus, the electrolysis reaction wasn't going to create a lot of oxygen to begin with, so it wasn't really worth it, though I made a note to build this apparatus later. I also noticed at this point that I couldn't relax after all, at least not as much as I'd hoped, because I really needed to get that first round of bricks for the tower setting now, so they'd be ready for me to build with tomorrow. I already had a little over 300 liters of lime stockpiled, which meant I would need to make another 1,000 liters over the course of next week. With the solar array, I can make about 80 liters per day, which would take me 12.5 days, so perhaps my previous estimate about being able to get it done in 1 week was a bit optimistic. Taking down the array put me back more than I expected. I should have most of the clay I need still lying around from excavating the pool. That left collecting pumice for fill, which I'll almost certainly have to do a little bit each day. make it part of the routine. I went and collected 1 load of pumice over the course of an hour or so, and then started making more brick molds in the ground, arranging them in a pattern around the base of the tower in an area basically equal to that of the walls I needed to build, just laid on the ground. After a couple of hours of digging in a somewhat stooped-over position, I prepared and poured the concrete and filled the molds in as twilight began to fall. Exhausted, I then got my clothes washed for the week ahead, took my shower, had dinner, and went to bed, knowing I didn't really get a day off today, and that I've got a lot more work to do tomorrow. That's just how life goes sometimes. And again, since I clearly haven't learned my lesson, this is the price I pay for not thinking ahead.
This is the blooper reel. Don't even think of it.
Don't even think about trying to escape. It'll just pump air until it fills up again. If one of the pots overflows, it's no big deal because there's plenty of water in the ocean. I feel like something's missing here. Hold on. I cut down some bamboo. Oh, me old bamboo. I poured the rest of my latex down the tubes. To act as pipes once the bamboo dried. It's not the bamboo drying, it's the latex drying. This is a mess. Where was I? To make a cylinder. And I left out to dry for the day. There's something missing there. Errors everywhere. Thinking to myself the whole time that this isn't itchy. It has a diameter of what the typos. For all practical purposes, this basically means I can make the bricks as large or small as I want. I sure hope I don't get roasted by some civil engineers in the comments. This is going to require me to build a tall tower out of coconut trunks. I took several sprouting coconuts. Croconuts? What sprouts from a croconut? Tree frogs, of course. Ba-dum-bum. And I tied A2 ropes. Pause. Since I'm going to be spending basically all of next week, and after that mad dash to build the elevator tower, 2 phrases you never want to hear in the same sentence, I could almost take a break. First, though, that's funny. Double negative. I just know that Hey there, thanks for listening all the way to the end. It really helps me out as far as telling the algorithm who to share my videos with. I'll be getting back to work on building the tower next week. Hopefully my calculations were accurate. So if you want to see whether it turns out to be a sky tree or a faulty tower, then you can press the subscribe and bell buttons to get notified as soon as the dust settles, one way or another. Now, I'm not getting paid for this construction project, but it would still help me out more than anything else if you could share this video with someone who you think would enjoy it. And since you apparently liked it enough to watch it this far in, you can press the like button and the elevator will take you all the way to the top floor, the Sunflower Penthouse. There's also a dislike button you can press if you didn't like it, but that'll just take you to a utility closet all the way down in the basement, and it tends to get stuck down there. I'll get around to fixing it someday. Also, if you'd like to talk about your own stories or perspectives on the episode, maybe about a time you got stuck in an elevator, or about your totally irrational fear of heights, or if you just want to chat about anything, please feel free to leave a comment down below. I genuinely love to hear them, and I welcome suggestions and corrections as long as they're constructive. That said, thanks again for listening, and hope to see you here again next week.